So we're going to talk about what is innovation. Anybody? What is innovation?
Evolution of something and taking it to a new, like where you create something new or improved.
That's right. So the question is innovation evolutionary or revolutionary? I explain. Revolutionary means something nobody thought about. You woke up at night and you have a great idea that you know how to make the earth turn the other way around, something. Evolution means, of course, step by step, step by step. What do you think innovation means? Evolutionary or revolutionary?
Both.
Both. Who thinks evolutionary? Nobody. Yes. Why do you think so?
Because not any innovation is disruptive, revolutionizing things. Some of it are just like the next step in something that already exists.
Okay. Well, who invented the light bulb?
Tesla.
Tesla. Who else? Any other name? Edison. Another name. Okay. When was it invented? Do you know?
19th century.
Yeah. When?
It's 1860, 60.
Very good. Very, very good. You're close. All right. So as you can see, it had a long history. Humphrey Davy from the Royal Institution in London invented the first incandescent light. And it was used later on in lighthouses because England, Britain was a very powerful naval empire with lots and lots of ships, and they wanted them to get safely to the harbor, so they needed lighthouses. So that's in 1803, 1809. Then in 1877 to 85, there was a lot of activity around it. And just to show you how much activity it is, 1809, first guy, Humphrey Davy, then James Bowman, then Frederick, whatever, and then a Russian engineer, and then William Sawyer, and then John Stevens, and then British inventor, and then finally Thomas Edison. Do I need the because I have a lot of pictures in some language. Yeah, it's evolution. Okay. So this is the light bulb that Edison saw. And why do we remember Edison? Any idea why we remember Edison? All of these long lists.
He brought it to the market. He brought it to the market to the general public.
That's correct. Very, very good. Exactly. So as you can see in here, and that's the reason I was talking about evolutionary versus revolutionary. And you can see a lot of people were playing with the idea. But Edison was the first one to bring it to work for enough hours to make it work. And so you don't want to be in a house where every 10 minutes or every 2 hours you place your light bulb. So he brought it to the point where it was 600 hours and later on 12. The other thing that happens in here is how do you power the light bulb? You need electricity, right? You need generation. Do you think there were generators before Edison did that? No, why not?
I think the technology wasn't there at the time.
Well, the technology was there. They knew how to develop a dynamo, which is a generator, and they knew how to develop an electric motor, which is the opposite of the generator. It's the reverse of the generator. The only problem was there was nothing to do with it. No phones, no computers, no anything. So the killer app for electricity was the light bulb. So And that's why Thomas Edison started General Electric, which was the first company that started to generate electricity. And it's a long story, I won't get to it at the moment. So that's what's going on here. So what triggers the evolution of innovation? I said that it's evolution. So something triggers, and surprisingly, many inventions were invented independently at about the same time. So what that tells you is that something triggers it. So if there is a certain development, it kind of tells people, here's the next step. It's just around the corner. And I'll show you a lot of these examples. The most striking example that I am aware of, and I'll explain in a moment why it's striking, is Darwin. We all know Darwin, right? In 1858, he gives the tendency of species to form varieties, basically natural selection, basically evolution. Right? We talk about evolution, which is why I brought it up here. And he worked on it for about 20 years, wrote the book, and never published, never talked about it. Does anybody have an idea why he didn't talk about evolution? Why for 20 years he didn't talk about evolution? What is the most striking element about evolution?
Religion?
Very good, thank you so much. Right. If we are from apes, then maybe the Garden of Eden didn't exist and so forth, so he would come into trouble with the church. Not that he was afraid of the church, but he was devout Christian, so it just didn't sit well with him. And as you know, in the US still, there are a lot of people who are what's called creationists. They don't believe in evolution, mainly because of religion. So he didn't want to talk about it. But then one day, a letter or an article comes to the Royal Society, where he was a member, from a guy called Wallace. Charles, what's his name? Alfred Wallace. And Alfred Wallace was a naturalist. He was touring India at the time, and he came up with the same idea as Darwin. And he wrote about it, and he sent the article to the Royal Society. The article came to Mr. Charles Lyell, and Charles Lyell was a friend of Darwin, and he told Darwin, listen, somebody else came up with the same exact theory. And Darwin said, good for him, very nice. So he insisted on bringing this guy, Wallace, and he called it the theory of Wallace and Darwin, because he was really a good guy. But later on, he wrote The Origin of Species, and he wrote a book. So Wallace insisted that he would get it, right, and not him. So it's one of those bizarre situations where the two inventors, call it, or the people who came up with the idea, were fighting who should get the credit, but the other way around. Kind of saying, he said, you. Very interesting. Now, I said that innovation is evolutionary. So what were the steps before that that brought this idea? So Lamarck preceded them. He came up with this idea. He said one species comes from the other, but his idea was that behavior during the life of the animal goes to the offspring. His famous concept was the giraffe. You try hard, so your neck gets longer, and your kids will have a longer neck, and if they try harder and harder, they will get longer and longer necks. Darwin said, no, these traits are not inherited. Surprisingly, for many, many, many years, we all thought that Lamarck was wrong, as it says in here. In recent 20 years or so, it turns out that there are certain traits that are are attained during life and are transmitted genetically. The most famous research about it is what's called the Dutch hunger. Dutch Holland. So in 1944, the Nazi Germany. They were occupying Holland, and they needed food, so they stole food from Holland. And the people in Holland were in hunger. But Holland was an organized, very well-run country. So we have records of pregnant women going through the pregnancy while there was hunger in Holland. And so what they looked at is later on, what happens to women, pregnant women in the first trimester, second trimester, or third trimester, where there is severe hunger. And they found that it has an impact on the babies, different impact in each trimester. Well, that wasn't a surprise. But then the babies, remember we're talking about 1940, then the babies had their own babies. Now we're talking about third generation. It turns out that the third generation also showed certain traits that came from the hunger of the grandmother. So we now believe, and it's called epigenetics, that certain traits do pass from one generation to the other through what happens to the first generation during their lifetime. Charles Lyell, remember I talked about him? He wrote a book about geology. And the most important element of that book was that the Earth must have existed many, many, many more years than we believe. Remember, the church said about 6,000 years. They just counted in the Bible how many years everybody lived. Then scientists believe it was maybe 10, 20 million years. Charles Lyell claimed that it was, hundreds of millions of years, because the geological processes are far slower. So that gave a lot more time for evolution to develop. The third person is Thomas Malthus. If you've never heard about him, you should hear about him, because he was an economist, and he believed that the population grows exponentially, food production grows linearly, therefore there will be hunger. He proved it mathematically. One thing grows exponentially, the other grows linearly, there will be hunger. Hunger will bring wars, people will die, and then the population will decline to what the food supply can support. So by the time Malthus wrote it, maybe there were about a few hundred million people in the world. We're approaching, 7 billion, 8 billion, I don't remember the number. And there is no hunger. So what happened? Why there's no hunger?
Directly correlated. We have more production as well, so we're producing more as we grow.
Agricultural innovation. Okay, so we produce a lot more food than he assumed we can produce from an acre of land. But anyway, what you see is they were influencers, and that's what tells you that innovation is evolutionary. We all rely on previous ideas, previous technologies, and so on. So there are many, many concurrent innovations. One of the famous one is Newton and Leibniz developing calculus. Anybody here knows what calculus is, right? No. Other calculus. Infinite, remember? You do an integral and a derivative. That's it. Okay? So they developed it concurrently, and there was a huge fight between them. Leibniz was French, Newton was British, and they almost went to war. The discovery of oxygen, two people, Charles Darwin and Russell and Wallace, the photographic methods, color photos, radio emission. You talked about Tesla. Here is Tesla. He was a great inventor, and that's one of the things he was working on. And the polio vaccine. Okay, so you see that a lot of things, once there's enough background information, technology, whatever you want to call it, many people come up with the same thing. I could have filled out the whole discussion today with this. Okay, so if it evolves one step at a time, It always relies on other ideas that came before it, or theories, or technologies, or even resources. Like I said before, you don't start doing electricity regeneration unless you have a use, but once you have the electricity, you can start using it for other things. And we will see that theme throughout this presentation. Okay? Now, what about product innovation, which is different than coming up with a theory or mathematical theory or an integral? When you want to do a product innovation, for it to succeed, it has to reach acceptable levels of price that people can buy it, performance, and ease of use. And we will see a lot about that. So this is a product that I developed called Cardston. And the reason I bring it here is that I did exactly what I was telling you. So I sold my previous company. I was looking for what to do. And I remember it one night, around 11 o'clock at night, wake up my wife and I say, I have a great idea. So what? So I said, listen, there's a convergence of technologies I can use. Scanners become smaller, and there's OCR, optical character recognition, that can read business cards. And I know how to develop the rest of the algorithms. I'm going to do it. And I did. But I needed OCR, optical character recognition. So I started calling, there were about 6 or 7 companies that were producing this technology. So I called them and I said, listen, I want to license their technology. And they said, what for? I said, I'm going to develop a business card reader. And they started laughing. I said, why are you laughing? And so I got 2 answers. Some of them said, oh, we're already working on it. And the others said, oh, stand in line. There are about 10 companies ahead of you. They wanted to license. So you can see the same theme of concurrent evolution happening again and again. If you have an idea, chances are there are 10 other people working. If you're the only one doing it, you're probably wrong. So just so remember that. I mean, I know everybody coming and say, an idea, great idea, nobody is doing it. And I say, well, in that case, you're going to fail. You want to find something that everybody is thinking about it. That means it's right for development. By the way, the company was successful because when I saw all of the stuff, I was in a trade show and we were just starting to develop. I had a co-founder. And there was a booth. And in the booth, they already gave demonstrations of the product, selling the product. So I called him. I was really depressed. And I said, listen, Dexter, people are already selling the product. And he said, okay, if we can't be the first, we'll be the best. Remember that. If you can't be the first, be the best. We were the last one now. It was a very good company. Okay, let's look at another thing. Electric car. So most of you probably think electric cars were invented by Tesla. Not really. We're talking about 1900, 1910. And actually, the electric car was the favorite. And the reason it was easier to drive, less noise, less pollution, no smell, and you don't need to crank it, which was very difficult for women. And it was very good for short drives. Remember, there were no roads, because if you don't have cars, you don't need roads, right? So the roads were pretty bad. Most of the rides were urban, like in the town. So they were their favorite car, the electric car. But then what happened is Mr. Ford with the Model T, which was introduced in 1908, and it cost $650. Remember, the other one was about 3 times as more expensive. The gas allowed longer range trips. The roads have developed since the beginning. And the electric engine starter, so if you push a button in your car and it starts, that was invented then. So no need for the hand crank. You can see it in a lot of the movies. No need for it. Crude oil was discovered in Texas, so there was a lot of cheap oil. And more than 15 million Model Ts were built. It's the second most popular car that was ever sold. The first one is, any guess what was the most sold model?
Volkswagen?
Good, the Beetle. That's right, very good. So by 1935, no more electric cars. Now, let's look at what happens now. So this is the number of, in thousands, okay, how many electric cars are sold. I look at from 2010 to 2019. 2010, virtually nothing. I don't have to tell you about this now. So what's the difference? What happened? Any guess what happened between 1935 to now? What happened in 2010? Yes?
I think both the conditions were better, technology-wise, and both the strategy that Tesla took was a lot better.
Good ideas. Any other ideas?
Maybe now all the other resources kind of caught up, meaning like eventually electric stopped being the most useful version of it. Now we're headed to more sustainable type of technology. This is where the innovation is more leading people. The market demand is more there than it was. Also, we have more infrastructure to be able to build that. We can build electric charging stations that could never existed back in the
Very good. More ideas. That's good. Okay, so let's read the answers. Global warming. So there's a societal pressure to move away from gas. Government subsidies. Now make it cheaper. Tesla. So Tesla is an interesting concept. I'm talking about the car now, not the bus. Most car companies thought about electric cars as a car that are replace the engine with electric motor. Tesla was built the other way around. They said, okay, we have a PC. How about if we put 4 wheels on the PC? Literally. And so the car is built with the concept of a PC. What do I mean by that? If you don't have an electric car, how often do they replace the operating system of your car? Never. There is no operating system. You buy it from the manufacturer and that's it. It's going to stay the same for all the years. Tesla, you get a new version every, I don't know, week, month, whatever it is, they download it to your car.
It updates itself, no?
Yeah, absolutely. It's a PC on wheels. Okay? The big screen, the whole concept is different, which is very interesting. Much better batteries, longer range. Why we have better batteries now?
Phones.
Good. Any other idea? Why do we have better batteries? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 laptops, right? Right here in this room. So let's look at it. This is how batteries improved from 2008 to 2020. About 9-fold improvement in the capacity of the battery. You can put a lot more power into the same size. That's why you can use all your computers for a whole day without charging. That's why you can walk with an iPhone for a day and not charge. So let's look at this. What caused the batteries to be better? So 1980, how many people use cell phone? Pretty much 0. How many people use it in 2020? 9 billion. 9 billion. So think again what I'm talking about, innovation, right? Every step leads to the next step. So you have cell phones, then you have laptops, then you have cars, because the technology now enables them to be affordable, easy to use, and convenient. Okay, now what made the iPhone? Why was the iPhone So I want to run a vote in here. How many of you use the phone that you have mainly for phone calls? 80% of the time you just do phone calls. Anybody? Raise your hands. No. How many people use it half-half? Half for phone calls, half for something else. You. Good. How many people use for phone calls just about 25%?
That include texting,
No.
just phone calls?
No. Just phone calls, like phone calls. How many people basically use it for everything else except phone calls? Most of you. Okay. Why? So what do you use an iPhone? How many use it for social media? How many people use it for social media? Good. Web browsing. Communication, WhatsApp, you ask, right? Okay, gaming. How many people use it for gaming? Oh, you're so serious, guys. Okay, here, somebody is. Navigation, Waze. Who is not using Waze? All right, other. So, what is the iPhone? It's a handheld computer with a GPS. That's what the iPhone is. So if you think about what Apple did, is they moved again, it's very much like a Tesla is a PC on wheels. The iPhone is a computer with a phone. So the innovation was really to think about it differently. Okay. So it needs, in order to do that, right, it needs a GPS and a connection to the internet. So let's look at that. What happened again? So for the internet connection on cell phones, you need to be on 3G. Today we're on 5G, 3G, that's the protocol for connection of cell phones. So that's, as you can see in here, that's when it started to be able to really do a lot of data heavy communication. That happened in 2001. When was the iPhone released? 2007, correct. Right? So just a few years before that, that was in Japan actually, so it took the time to get to the US. But 3G enabled the communication. GPS. So GPS was introduced in 1999. In 2000, the US government, Bill Clinton, signed a law that basically said we're not going to mask the GPS. Before that, they were afraid that it's going to be used for military purposes by their enemies. So they made the civilian use not very accurate, not useful. And in 2001, personal GPS products started to spread. So you can see again, enabling technologies bring the next level of innovation. Now you see why I insist all the time, evolution. And we will get to it later. Why is that so important for you and us? So, what happens now? So I can tell you one thing. What we see people do with their smartphone is just the beginning. Why? Because look at what it has. It's always connected to the internet. So what do we do with it? Spotify, Netflix, Zoom. So we started using it for things that we never thought we would use it. It's powerful enough to run sophisticated applications. It's a really powerful computer. It's much more powerful than the Apollo computers that landed on the Mars. And it's in your pocket, or at least in mine. It's very easy to develop new applications. Interestingly enough, there is another innovation that drives a lot of these things that you take it for granted so much that you don't even think about. So how many platforms we have for phones, for smartphones? 5, 10, 15, how many?
Like software? Software?
No, phones, you use phones. What types of phones do you use? How many?
Hundreds.
2. There is an iPhone and there's Android, right? Microsoft doesn't have an operating system. Nobody else has. There are 2 phones, period. Regardless of who's the manufacturer. There's one Windows, right? It can run on Asus, it can run on HP, it can run on anything. But there's one operating system. Actually 2. So you have to remember that. This is tremendously important. Why? Because it means if I develop something on an iPhone and on Android, 2 operating systems, I can reach 9 billion units. 9 billion units. And most development platforms, you develop it once, you push a button, you get 2 versions. That releases tremendous amount of time and energy for you to be creative, because you don't have to then translate it to Chinese, to German, to French, to whatever it is. Just think about, we speak English in here. Why? Because it became the language that everybody understands. Even though most of you don't use it day to day, you use it. So that's the power of standards. It has a camera, a microphone, and high fidelity speakers. So when you listen to music, you enjoy it. Think about the power of what you have in your pocket. High quality screen. What does that mean? Think about what I wrote in here. How many of you have a physical album? Shame me.
Old one.
Old one, right? You? If I were you, I wouldn't be here. Look at the difference. You see the difference, you see the changes it brings, okay? It's a huge change. I laugh at my daughters. If they don't take a picture, it never happens, right? They go to a restaurant, they take a picture. Say, what, you can't eat without taking a picture? No. So it changes our lives by having this camera and high quality camera in our hands all the time. It has enormous memory. Many, many, many years ago, way before you were born, I went to Yonatan. I arrived there in computers, and they told me that for a week, the mainframe is going to be down because they bring in memory to expand the computer. And trucks arrived, and they had just huge refrigerators, and took it down and put it in there, and they added 8 megabytes memory. It's huge. So this is something else. There's a GPS. Look at all the applications that use GPS. Just Waze, Pango, Uber, Get, Vote, many more. And there are many more useful apps. And I haven't even started talking about the business applications. Okay? So if you just think about insurance, no insurance agent now comes and doesn't take a picture of the dent in your car or whatever happened in your house, right? It became, there are a lot of applications, by the way, medical applications. I think even in Maccabi, right? If you have anything in a lesion on your skin, you can take a picture, send it to a doctor for evaluation, right? So this is a tremendously powerful tool in the hands of 9 billion people. Remember what I said about innovation. It's evolutionary. Once you have everything in place, a lot of people will come up with the next great idea. So you are the next great idea. Start thinking. Okay. So what else do we need? I'm talking about enablers. So that's the term I'm using in here, is to say what enables the next set or wave of innovations. And there are many. I talked about one of them, which was the iPhone. But let's talk about others. Talked about standards, right? So the world has moved into standards and trying to move into standards as much as possible. And the reason the world is moving towards standards is because it makes things simpler. You measure in meters and centimeters and kilometers. It's the metric system. There's one country that doesn't use the metric system. Anybody knows which country doesn't?
US.
United States of America. Why? Well, it's actually quite of interesting why. Well, they talked about it, obviously, many times, and they figured out that the cost to convert to the metric system will not be recouped because America is so big they can manage living in their own kitchens and yards and whatever. So let them get lost. That's so they don't want to change. But other than the US, the whole world is using the metric system. Now, you guys know why one of these satellites that were sent to, I think it was Mars, to crash. It turns out that two vendors were building something. One was using metric system, the other was using the inch system, and they never found out that they're talking about the same number, but so the lander crashed. Another platform is the browser. All of you take for granted that there is a browser, but actually there are several browsers, but they all use one underneath operating system called Mozilla. So regardless of the computer you use or the phone you use or whatever it is, you can read any HTML. Just think about it if you had to develop each HTML page in 5 different flavors. So standards are tremendously important. Give you another example. You want to charge your phone. Right? You have a charger. You travel with the charger. You ever think about, oh, should I put it in the power? Is it 110, 220, whatever? No. Why? Because there's an innovation now that chargers can work on any voltage from 100 to 240. Again, standard, it produces 5 volts. You have enormous computing power at your fingertips. That has tremendous importance, and I'll talk about it later about deep learning and all that stuff. So there's huge amount of computing power nowadays, literally at your fingertips. Where? In cloud computing. If you want to develop something, you go to Amazon, open an account, and you can put 1 server, 2 servers, 10 servers, 500 servers, 2,000 servers. The click of a button. And you pay for the hours that you use. That's it. So if you need to do some very complex computations for 5 hours, you just turn on 100 computers, you turn it off, and you pay for 100 computers an hour. It's not that expensive. It's much cheaper than buying these computers, installing them, having to live with them. It's much cheaper. The fact that you can turn them on and off like that makes it unbelievably inexpensive and easy. You just sit at your computer at home and you can do it. It has built-in technologies that come with it. First of all, scalable architecture we just talked about. They come with databases, so you can immediately use a database because you just turn it on. It comes with search engines like Elastic. And it comes now with artificial intelligence. So what am I trying to tell you? Basically, if I compare it to my days at Shmone Matani or at my days in my previous companies, where if I wanted a computer, I needed to buy a rack, computers in it, turn it on, manage the whole thing. Nowadays, each and every one of you can be a rocket scientist, literally. All you need is a credit card. You want to be a rocket scientist?
Think about it.
Good. Now is the time. SpaceX and Amazon AWS, and you're a rocket scientist. Okay? So these are enablers. That means that the innovation we can go through now can move much faster because it's accessible to us and it's easy to do. There are powerful technologies, deep learning algorithms. So let's talk a little bit about deep learning. Anybody here knows how the brain works?
With the neural network.
Good. So the brain has neurons. The neuron is a pretty straightforward, simple thing. It's a cell. There's input, it has one output. The inputs are called dendrites, and the output is called an axon. Right? What happens is, as the inputs come in, if they pass a certain threshold, it fires. Really simple. I won't go into more details. That's enough for what I'm trying to say. So scientists developed this idea, and it was called perceptron. Not surprising, perceptron. Right? That was developed in the 1950s. Remember I said input and output, right? So you can put a network on. So they put a network of perceptrons, inputs, output, everything is great. But computing power was not high enough. So they were able to do, you know, maybe 10 perceptrons, 3 layers or whatever. It was kind of not very interesting. So it was an idea. We say, well, we had a theory about how the brain might work, but it's not really very interesting. That changed in 2010 for several reasons. Number one, computer power, if you compare it to the 1950s to what they had in 2010, 60 years later, it was like a million-fold. It was inexpensive. So they can start putting much larger networks than they used to be. Second, how do you train them? You want to do something with it. And in the 1950s, Harvey Minsky was a professor of computer science, and he tried to play with artificial intelligence. And he came up to some very profound observation. He said, what's hard for people is easy for computers, and what's easy for people is hard for computers. So what do we mean by that? What's hard for people? How many of you know how to solve differential equations? No volunteers? You wanted to be rocket scientists. Differential equations, right? Easy. What computers doing? Very simple. Not simple, but they can do it. But until recently, if you ask the computer, is that a picture of my mom? No. Image recognition was an unsolved problem. A lot of professors thought they're professors because of image recognition. I don't know how many hundreds of PhDs were being. No, with feature extraction and you name it. Translation, unsolved problem. Totally unsolved. All of these were solved with these deep learning algorithms. Basically, were just very large networks of perceptions. The other thing that moved this process forward was the ability to train these systems on huge amounts of data easily. What do I mean by easy? If you wanted to train it on face recognition, you needed to have millions of pictures of faces with a tag. Yonatan, 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 here. You know, this shirt, other shirt. It was difficult to do. Nowadays, you just go to Facebook. You have as many millions as you want of labeled pictures, right? So it became really simple to train it on millions and millions of examples. Why do I keep saying that? Because it turns out that these algorithms need huge amount of training. That's what makes them accurate. Now, you say, wait a minute, we don't train ourselves on this. How does that happen? Well, that's a mistake. You walk with your eyes open 20 hours a day, 15 hours a day, and you move your head all the time. And you train your brain all the time to keep the input. Because what happens is that as you move your hand. The image that falls on your retina changes as you move your hand. You don't feel it because your brain is all the time extracting from it the image that you want to see, which is my face. So your brain is doing exactly this training all the time because you were doing it from the day you were born. You don't see it anymore. It happens underneath. That's what they did in here with deep learning. Translation. So how does translation work? Let's make sure that I'm not running out of time. So the easiest or the simplest translation machine is called a dictionary. Right? So all you need to do is you read a text, you go take a word, go to the dictionary, and everything is fine. So why do we need to have any more sophisticated stuff? Well, it turns out that a word-for-word dictionary will not get you too far. So then what they started doing is they built dictionaries that have more than one word. I sit, I go, I will, I am, all of them are in the dictionary. So I train it on 2 words. But how do I divide the text into 2 words? Well, I do it with an overlap, right? 2 words, then 2 words. So one of them is an overlap. And when I translate, I need to make sure that the middle one is the same middle one for the 2 words. So they developed an algorithm. How do you find the best path when you do these 2 words, 2 words? What about 3 words, 4 words, 5 words? So Google Translate works, if I'm not mistaken, with dictionaries of 7 words, with an overlap of 6 words. And they train them on a huge amount of text that they have in 2 languages. The easiest example is French and English. Where in the world do we have huge amounts of text, identical text in French and English? Any Canadians? Nobody.
I have a passport.
Well, Canada, of course, have a province that speaks French because it used to be French. And they are very, very strict about speaking French, and every document has to be written in English and in French. So they have huge amounts of text in French and in English that are identical content. So that's just an example. Obviously, they do it on every other language. That's why they can translate with the same exact algorithm, virtually from any language to any language. If you go to Google Translate today, translation is unsolved. Amazing. Speech to text. Same thing. Unsolved problem nowadays. If you look at the presentation in Zoom, you will see the text underneath it, done in real time. Now, it's embedded, YouTube, Zoom, and so forth, but there's also business tools for it. In sales, they use a product called Gong that records sales sessions, analyzes the text, and gives you advice what to do or not to do. Always the same thing. Customer service, your call will be recorded, right? What do they do with it? Speech to text, figure out what people call for. Legal. Every legal, you go to court, they speak. It's recorded, and then speech to text. Police, intelligence services. NSA, FBI, they listen on millions of phone calls. They do the same. Picture recognition, we talked about, right? So again, we have it embedded, Google Pictures. My favorite game is when I meet people, I said, you know that your phone recognizes? And they say, no, I never saw it. So I tell them to take their phone and write the word dog. And suddenly they see pictures of dogs on their own phone. Say car, and they see pictures of cars. And they're like shocked. How does it do it? Honestly, I don't know, but it does it. Play with it, it's really fun. Security. Okay, so you wanted innovation, I'll show you innovation. Just an example to show you what happens when you have these enablers. Remember all of the work in enablers. So there's a guy, okay? His name is Juan Tom Tat, whatever it is, probably. but he lives in New York. And he came up with an innovation, a really simple idea. He said, okay, I can do face recognition. So if I go to LinkedIn and Facebook, I get pictures and information about the person. Then if I go and I look around, I can find more and more pictures of that person, and I know who the person is because he gave me on LinkedIn his name and where he is and everything. So this guy built a system where it had, I don't know what it says in here, 3 billion images scraped from various websites. And essentially, you can license. You can put it in your fashion store, and when you walk in, what's your name? Yeah. I know your name, you see, because I can use it. So that obviously caused some people to say, oh my God, what's going on here? And there is a privacy commissioner launched an inquiry. It's a very controversial application because of the implications. But we're talking about innovation. So think about how this person used everything that I said, all the enablers I was talking about, and did it really simply. Because you can do face recognition. It's very easy to scrape LinkedIn or Facebook and all of that stuff. All of this is really easy because you have Amazon AWS, you have all of the technologies available. Probably took him, a few months to develop this. So you start to understand the power of enablers. ChatGPT, another language model. So that's the next enabler that we see today. High quality verbal man-machine dialogue. What can you do with this? Think about the following application. You get home in the evening and you say to your TV, I want to watch a movie with the same actors of the movie I saw last night. And it will just give you a list of movies. ChatGPT has two things. One is far more interesting for me than the other. It can answer your questions, it's okay, but it understands your question. That's a huge breakthrough, huge breakthrough. Look at all the user interfaces that you have today to your phone and everything. They all are very mechanical. ChatGPT will allow it to be much more human, normal. You can talk to it and it understands you. And that is going to have huge impact on everything. For example, it can do a lot of text extraction. So I'll give you an example. ZoomInfo, company I started. So what ZoomInfo did, I started in the year 2000, was a great idea, innovation, saying I can scan the internet, extract information about people and companies. How? I read sentences and I understand them. If it says Yonatan Stern was promoted to VP of sales at XYZ company, I understand that. I say, oh, if he was promoted, then he works there. Okay, I can put Yonatan Stern in company XYZ that I am vice president. Understanding language. If I go to the site of company XYZ, I click on the about, I click contact us, and I see, oh, here's their address. Boom, I connect the address to the company, right? So that's what we built. We worked really, really hard, and we built a really good technology and a good company. But it's nothing compared to what ChatGPT did. Nothing. Give you another example that people are working on. There's a huge amount of information in your medical records. But nobody is organizing it because it's hard to understand. I'm not talking about medical tests and so on. These are just numbers. But you go to a doctor and he writes something. In the hospital, they write something. To understand it and combine this information from millions and millions of doctor visits and hospital visits would create a phenomenal tool for diagnostics and for treatment. And a lot of people are working on it. And with ChatGPT, it can make a huge progress. The technology is so new that we just started scratching the surface. So I encourage all of you to keep scratching. I'm serious. If you're looking for innovation, digital innovation, there are so many enablers now. It's so easy and it's so inexpensive. So additional technology enablers, not just computers. Drones. What do you do with drones? You can buy a drone for $500. It's good. What do you do with it? Well, a lot. Well, now any wedding photographer that shows up without a drone is not professional, right? So sunset, garden, and all of that stuff. So that's kind of would say the lowest innovation possible. Agriculture. You can see your fields or your orchards from the bird's eye view and figure out a lot of things. A lot of use of drones in agriculture. Policing, obviously, right? Somebody stole your car, it's much easier to go after it with a drone. Military, I don't have to go over that, right? Fortunately. Archaeology. I just read an article the other day about using drones to go over the Amazon forest and discover old civilizations there. The remains are so big you couldn't see them from the ground, but when you go up, you can see a structure. 3D printing, same thing. Nowadays, a lot more and more stuff is being done with 3D printing. DNA manipulation. I won't go into what CRISPR is, but essentially it allows you to almost do digital editing on DNA. It's a molecule that can go along the DNA, figure out the location you want it to do, take something out, put something in. So, interesting story. But really what it does is treatment. Right now they use it for treatment for genetic defects, and they play with all kinds of things. But professor in Korea decided to do an experiment. And he made some genetic changes to 2 embryos to make them immune to AIDS. And then he published it. And he was sacked from the university because there are a lot of conventions that say you are not going to play with human embryos. And it worked. And the babies are alive. That's right. So really what stands between us and producing full-blown geniuses, it's not that. Now let's take you a little bit beyond that. Right now, if you want to have an apple, you plant a tree, apple tree, and you tend to it for a few years, and then you have to pick the apples. But each apple starts with a single cell somewhere that later on divides and becomes an apple. When we understand the technology or the process by which one cell becomes you or you or you, one cell. Remember, at the end of the day, you started from one cell. And your dog started from one cell. The dog is not you. So somewhere along the way, there is an algorithm that decides how this cell divides and divides and divides and turns out into a dog or you or me. And we are on the road to understanding it. We talked about meltdowns, right? As the population grows exponentially and food grows linearly. I'm willing to venture and say that in the next 20 to 30 years, if you want a steak, there will be a machine where steaks grow, literally grow. And not because, we assemble cells, but because there's something in there that multiplies and grows, but it produces, instead of a dog or you or me, it produces steaks. That's all. And when you want a steak, you just cut a piece of steak. That's it. And you take it. And think about what that is going to do. So we're talking about technology enablers and digital innovation. Self-driving cars, right? Not perfect at the moment. Huge amounts of money involved in it. But think about the impact on it on urban life. Because the car is the most wasteful real estate we ever had. Takes space in your house or near your house, on the street. You drive for 10 minutes or half an hour, and you take space somewhere. If you live in Tel Aviv, this space is tremendously expensive. But why? You don't use the car 90% of the time, 95%. If instead you can tell your ChatGPT, bring me a car, I want to go to work. He says, yes, sir, it will be here in 3 minutes. That's much easier. And you walk down, get into the car, takes you to work, and then somebody else is somewhere. Right? And this is going to happen. It is going to happen. What else? I don't know. It's innovation. So I leave it with you. Okay. So what's the impact of it? The most important thing I want you to understand is the technology is not what you're in business kind of. So all of this was very theoretical. At the end, it's not the technology, but how and where you use it. Okay, so that's the business innovation. So, for example, taxi service. The last thing you would think about is high tech. Taxi service. What can be more low tech? But look what happened when you put the technology. You have a phone with a GPS and communication, right? That's all what you have. And look what it did. Uber, Lyft, Get. Anybody here wave a cab? Nobody waves a cab anymore. Right? So you have the digital innovation we were talking before, and you now need to look at the impact it has on industries and uses. Hotels, travel. I remember when I wanted to travel, I picked up the phone, called my travel agent, and we were talking and said, oh, I have this flight and that flight. No. Nowadays, you go on Expedia, Bookings.com, kind of TripAdvisor, Airbnb, you name it, right? I don't know if there are any travel agents left anymore. Movie theaters. Some of you still go there, right? Mostly not to see movies, but because it's fun and go with friends. And, right? If you want to see a movie, you see it on Netflix. That's the reality. Why? It's interesting. Before that was Blockbuster. Anybody here remember Blockbuster? That's the question. Yeah, I'm not talking about it. I wanted to explain to you why Blockbuster went out of business. They knew about streaming. Postal service. Remember that? Post? Well, I actually had to do something, and then I needed to send a document to the Salada. So I get an email with a document I need to fill out. And an envelope, self-addressed envelope. And I'm like, why don't I just scan it and send it to you by email? An envelope. Where do I put the envelope? Literally, I asked my family, do you know any mailbox around here where I can put the mail in? When was the last time any one of you put a mail in a mailbox? Okay? Let's think about it. Dating. I guess some of you, I don't have to tell you about it. But look at the variety of industries or uses. They all use the same enablers I talked about. Same exact enablers. But look at diversity of applications. And you can add about 20 more or 50 more. That's your job. You're young. You learn how to do digital innovation. So every domain is like that. Okay, so you say, well, remember, if I'm the first to do it, I'm going to get all the benefits. So what are the benefits of being the first? Yes.
First of all, you have more experience because you're the first one to do it.
Yes.
So everyone's you're ahead of everyone. There's no one doing what you're doing. So
Very good. Very good. Any other additions? Yes.
Are already on your platform. So if another competitor will come, they'll need a good enough reason for them to not only to go to them, but to move their account from somebody else.
Very good. Any other reasons why it's good to be a first mover? Yeah.
that if you're the first mover, the other service has to be at least as good or better than you. It's something that's not as good as
Very good. So we would expect.
What about pricing? What about pricing in the first?
Talk about it. Good. So it seems like no competitors. The market is all yours. You set the standards, right? You decide what the product does and how it looks. You set the pricing and the packaging because you're the first. You can get patent protection even because you're the first. And the sweetest part is that your name is all over it, right? So Kleenex is a big brand, and Xerox, you know, you take a Xerox, right? Many times the Xerox is not done on a Xerox machine, and so forth and so on. And an iPhone people use an exchange between an iPhone and a smartphone, right? So the world is yours, right? You can do whatever you want if you're the first one. Is that correct? So let's see. Okay, social network first movement. Real life. So Facebook is 2004. Classmates is 1995. Still alive, active. 20 million website visits per month. Then there was Planet All, 96. 6 Degrees, 97. 2002, Friendster. Then LinkedIn, 2002, still alive, active, kicks ass. High Five, MySpace, Multiply, Facebook. Bizarre. First mover, not to be found. Remember we talked about it when we talked about the light bulb. First movers. Nope. Didn't go. We'll talk about why. The interesting thing is not just first movers, but when big companies try to do something, it's not always easy because of what you said, right? That you need to move them from one platform to the other, which is not always easy. So Amazon tried, called Planet All, they acquired them. Doesn't exist anymore. Google tried 3 times, I think. Orchid, which was again another acquisition, if I'm not mistaken. Google Buzz and Google Plus. They don't have social media. Microsoft tried. Yahoo tried. They all failed. Just interesting. What are the conclusions from that? I don't know. But I thought it was kind of interesting to see.
Not about branding, really?
I think there, because social networks really has a network effect. So you have to go where everybody else is, or else you're in the desert. So it's very hard to meet people because you need to move all your friends with you. So it's kind of more complicated. Didn't stop TikTok. So don't ask me. I have a lot of answers, but many more not answers. I don't know. But I thought it was interesting to show. Okay, search engines. Again, we all remember Google, we know Google, but it started actually in the early days of the internet. I don't even know what these guys did, Chuckhead, whatever, I don't ever saw them. In 1994 started to be things that I remember, web crawler, Lycos, InfoSeek. were very famous. And look at that. Lycos was the fastest to go from inception to IPO in Nasdaq. Okay. It was huge, huge growth. Okay. But here are the other ones. Yahoo in 1994 still exists. About 1% of the market. Google with 91%. Microsoft, Bing, okay. Again, 1998. So you see that really it wasn't the first movement at all. Why Google won, I can give you an explanation not now, but there is a reason. And you can see that the other ones that survived, Yandex, Baidu, and so forth, are actually about locales, you know, Chinese market, the Russian market. Okay, let's talk a little bit about MP3 players. Again, first movers. This is solid state cigarette box, 1979, Kramer's vision. 1979, came up with this concept, but he was unable to get funding and never put it into production. But he had a patent. Then, in 1998, came a Korean MP man. This one was actually a pretty good success. They sold about 50,000 units in the first year, about $200 each. But I want you to read the quote. No matter how the Korean staff tried to explain what an MP3 player was, people didn't understand why they needed such a device because they could listen to music with CDs or cassettes. Why do I need that? Remember that if your innovation is in business, you need customers. If people say, I don't get it, I have a CD player, why do I need it? Sometimes I remind my daughters that in their short life experience, they started with a cassette, they got a cassette, then a CD player, then the iPod, and now Spotify. So in a very short period of time, they moved through so many generations of music players. So here are the first movers. 1998 Diamond, 1999 compact personal computers, Ryoport, market is flooded. So by the 2001, the market is flooded with things. But what happens next? The iPhone started 2001. So Apple was not the first mover. This is what happened. Why? I will explain later, probably in the next class. But you can see in here again that what we think, okay, you have to be the first mover, I have to move fast, might not be the best strategy. So this is what we thought at the beginning. And what are the disadvantages of being first? Anybody can guess what are the disadvantages of being first?
You make all of the mistakes that people learn from.
Good. Very good. What else?
You might not have a proper understanding of what your customers are looking for because you might have an idea of what you want, but you don't know what the global market wants, and you have to really specify technology.
That's right. What else?
You encounter the first resistance. I mean, people usually resist changes in developments. And when you're the first one to hit the wall, and the next one is just jumping.
Good. What else? Good answers. Very good answers. There are many reasons for why you fail. That's why I keep asking you. What else? Okay. So no competitors, right? The market is all yours, but there's no market. Okay. If you remember what I told you, if you're the only one who invented it, you're alone, you're in the desert. You need to create the market, you need to explain what your product does, and you need to convince people why they should care and take action. Take action means buy. Not simple. So let me show you examples. I want you to describe, I want to show you a description of the product, and I want you to tell me what you think about this product. Touch fastener. Product is used for closure consisting of a piece of fabric and small hooks that sticks to a corresponding fabric of small loops. Swiss electrical engineer. Anybody can explain to me what this product does? Anybody recognizes this product?
Velcro?
Very good. I'm very proud of it. Why? Because it's very difficult to explain a new product. It's easy once you know what it is. So first movers have this problem. How do I explain the product? Okay, explain to me what this product is. Portable document format is a file format developed in 1992, captures formatting. What does it do? Anybody can explain to me what does it do? Guys, study digital innovation, digital, something. It's better than Velcro. Any idea?
PDF.
Yeah.
It's PDF.
PDF, of course. So 1992, I was already grown up, and Adobe launched PDF, and honest to God, I didn't understand what they wanted. Literally, for 2 years, I read ads, and I didn't understand what they wanted. Now, because it's not, everybody knows it. So how do you explain a new complex product? So I went on a website of one of the VCs and just copied what they say about their companies. Can you guys explain to me what InfiniPoint is doing? Don't feel bad because I don't understand either. But that's the problem. Okay? They come up with a product which is true zero trust security posture for devices. What is device identity as a service security category? God knows what the hell they're talking about. The vast majority of companies that start with an idea look like this. So just so that you believe me, here it is, another one. It's the leading InsurTech provider of a cloud-native, data-driven insurance management systems using an OPI, an open API architecture, blah, 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 blah. Very difficult. If you are the first mover, extremely difficult to explain what you do. We'll talk about that a lot later on. So, you are the innovator. What are the advantages of being first? We talked about it, right? The solution, here's my solution to you guys. Sounds horrible, but we'll talk about, remember the business of digital innovation, that's what I'm about to talk in the next meetings, is to tell you how you start a company with innovation. Being the first is the wrong perspective. I can recommend, if you have time, to take a look at this, The Innovator's Dilemma, with Clayton Christmas. I think it's one of the few books that really have a strong theory behind it. What he was trying to figure out is how come big companies fail and young companies succeed. Let's go back to Blockbuster. Do you think that Blockbuster didn't understand that streaming is coming? Anybody here thinks that they didn't understand that streaming is coming? Do you think Kodak didn't know that there is going to be digital photography? So why did they fail? Well, the reason that companies fail is because there's very strong forces inside the company. They just cannot make a change. Give you an example with Blockbuster. Blockbuster had, I don't know, 2,000, 3,000 stores. Right? Each store, in order for you to walk into a store and feel like, wow, great, I can pick a movie anywhere I want, has to have, I don't know, 5,000 cassettes on the shelves. 2,000 cassettes on the shelves. So think about the amount of inventory they needed to have in the stores in order to serve their purpose. Hard inventory, expensive. Then came Netflix. And their idea was, I'll send it to you by mail. They didn't have any streaming. They just had a concept that you can subscribe, like a library. And you click on the computer the movies you want, and they send it to you, and you can have 2 or 3 at the same time. And then you send them back, and you can get it. That solved their inventory issue. They had very little inventory because all their inventory was in the hands of people, was not sitting on the shelf. So for them to move from sending it by mail to streaming was very easy. They didn't have to change. For Blockbuster, that means they needed to get rid of hundreds of millions of dollars of inventory in order to move and change their business model. So they were not stupid. It's just that their business model prevented them from doing it. Kodak was a chemical company. They knew how to produce films with coatings, very thin coating that are sensitive to light. That's why I asked you, how many of you have an album? You don't need it anymore. You don't print it. So they were doomed not because they were stupid. They actually invented digital photography. They just didn't use all their huge investments. So that's why I think that it's very interesting to read this book, which talks about how to solve this problem. I will talk about it next time. Thank you.
Thank you.